Hello, in this lesson, we're going to talk about one of the most important identities, which lays the foundation for the rest of the identities that we often need to use, which is a cosine of A plus B. The identity to be proved is actually equals to cosine of A multiply cosine of B, subtracting sine of A multiply sine of B. Okay, so in this episode, we're going to prove this identity. Before we prove this identity, of course, we declare that we still work on this three pillars of trigonometry on that stage set, okay, with the angles are measured from standard position. Angles are positive if measured counterclockwise from the standard position. Angles are negative if measured clockwise from the standard position. And, all the inputs for sine, cosine, tangent, cotangent, secant, cosecant, their input are measured in the angle measurement way. And the outputs for arc sine, arc cosine, arc tangent, arc cotangent, these angles are also measured according to angle measurement rule. And we understand the reference angle is a different issue. The reference angle is the positive acute angle between terminal and x-axis. And then according to the definition, right, we have derived much, right? So this is the original form of definition. And, the point x comma y is on the terminal sides of the angle other than the origin. And I tweak the form in the latter form right here, as you know, for the reason that we can see better their relationships. So we're going to prove, okay, in this piece, we're going to use geometry. Okay, the proof is in geometry, but it's also done on the unit circle. Okay, so here's the picture. Okay, we are to prove this identity. Okay, so on the unit circle, we have the origin. The origin, of course, is O. It's not marked because we don't really need it. On this unit circle, okay, we have an angle A, angle B. Okay, so angle A is measured from the standard position. Okay, so angle A is measured from the standard position. And then angle B is measured on top of it. So this whole thing is A plus B. Okay, the whole thing is A plus B. You can see A plus B right there. Okay, now here we have the A measured counterclockwise, and we measure a negative B from the standard position. So we measure a negative B. Okay, now if you look at the opening of angles, okay, there are two A plus B. Okay, one is the A plus B here, which opens towards this arc length, which is P1, P2, P3. This arc length facing A plus B. Now, there's another arc length, which is angle A, negative B, but this absolute angle, this piece is also had the same arc length. Okay, so this piece arc length P2, P3, P4 are the same arc length as well. Okay, so let me write it down. Reduce the number of columns. Okay, so the arc length, of P1, we can say P1, P2, P3. Okay, so this arc and the arc of P2, P3, P4 okay, P2, P3, P4, these two arc lengths are the same. If you look at the absolute lengths, okay, as a result, the secant, the line connecting P1 and P3, okay, so the straight line connecting P1 and P3, okay, so this length connecting, which is a broken line on the picture, is the same as P2 with P3. So P2, P3, I'm sorry, P4, P2, P4, this length, this line segment is also the same as P1, P2, P3. So these two lines are the same. Okay, and according to this observation, we are going to set up our identity. We're going to prove our identity. Okay, so let's look at the points marked. P3, okay, start with P3. P3 is the positive directions of x-axis, which crosses the unit circle. So this point is 1, 1. Okay, 1, 1. Okay, so let me see if I can mark the points. Okay, we can mark the points, right? Let me see if I can make these, insert some rows. 1, 2, 3. There you go. Okay, so point P3 is a point of 1, 0. Okay, XY, right? P2 is on the terminal of A. Therefore, the coordinate of P2, which is on the unit circle, is P2, which is going to be cosine A, sine A. Cosine A, sine A, right? P1 is on the terminal of angle A plus B. Therefore, it is a cosine A plus B, comma, sine of A plus B. You can see all of these is gone by definition. Now, P3, P2, P1, last one is P4. P4 is on the terminal of negative B. Okay, P4 is on the terminal of a negative B. So according to definition, P4 is going to be the point which is cosine of negative B and sine of negative B. Okay, but cosine is an even function, sine is an odd function. So as a result, P4 cosine of negative B is going to be P4. This angle cosine of negative B is going to be cosine B. And sine of negative B, sine is an odd function, therefore it's going to be negative sine of B. Okay, so here we got all the information we needed. And next, we're going to find the length. Okay, we're going to find the length. How do we find the length of line on the rectangular system? Okay, so here we have a definition. Okay, I'm sorry, we have a formula. Okay, And this formula, I'm going to put it over here. Okay, for any 2 points. Okay, for any 2 points. Any 2 points. Okay, x comma y, x1, y1, and another point, x sub 2, y sub 2. Okay, the distance between the 2 points is distance equals to, okay, the distance, I'm going to write it down here. The distance is going to be the square root of x1 minus x2, x sub 1 minus x sub 2 squared plus y1 minus y sub 2 squared. And we're going to apply these two formula. We're going to apply this one formula to find P1, P3, and P2, P4. Okay, in other words, we're going to find the distance between P1 and P3, this broken line, and P2 and P4, this is straight line. Okay, so now we take these and we're going to apply these on the point P1, P3. Okay, so on P1, P3, okay, so our distance is going to be like this. This is our distance. Okay, this is our distance. I'm going to take that distance. Okay, between P1 and P3, P1, P3, this is our P1, and that's our P3. P1, P3. In other words, we can regard this guy as X1, X2, X1, Y1, X2, Y2. And then we just plug in, okay? So now we're gonna plug in. We're gonna plug in, okay? Here we go. X1, we decide is gonna be cosine A plus B, plug in. X2 is 1. So minus 1. Y1. Y1 is sine A plus B. And Y2 is 0. So this is 0. Okay. So we're going to organize our term. And we got the next one. Okay, cosine A plus B squared minus 1 plus sine A plus B minus 0. Minus 0 is just like that. So we can put the square right here. So we can put the square right here. Okay, so this is the P1, P3. This is a P1, P3. Okay, P1, P3. Can we organize this term a little bit more? Can we organize this a little bit more? Surely. Okay, P1, P3. Okay, we're going to open up the parentheses. Okay, open up the parentheses. When I opened up this parentheses, okay, it is actually, it's more like we're looking for x plus y squared. Okay, this is like x minus y squared. So this is a minus, right? And that should equal to what? That should equal to x minus y multiply x minus y, right? So it should equals to x squared, if you FOIL or by formula, 2xy, 2x times y plus y squared, plus y squared. So this is the formula we should be using, okay? So now we put this on the side. We put this on the side. Okay? We put this on the side. And our capital X is cosine A plus B, and Y is 1. So this will be equal to cosine A plus B squared. So that's cosine squared. Minus 2AB minus 2 times XY, right? 2 times XY. 2 times XY is 2 times cosine A plus B plus y squared. Y squared is 1, so this is 1. So with this piece done, we're going to take this piece, replacing that part, which is equals to, okay, I'm going to put it over here. And this piece will be replaced by that identity, that equal piece. Okay. Once this is done, we should notice that cosine square A plus B, and there's a sine square A plus B, and they're plus. So we can bring these two terms together. Bring them together, but they don't have to be bring together physically, right? But if you bring them together, we see better. So this piece is equals to 1. Right? We just learned that sine. So that is from basically sine, right? Sine of square of any angle of any whatever, right? Let me use a symbol that has never been used. Sine of any angle plus cosine squared of any angle equals to 1, right? So that omega is really that A plus B. So sine square A plus B plus cosine square A plus B, that equals 1. So next, we combine these two, 1 plus 1, that's going to be 2. So P1, P3 equals to that. So we got this, right? So we got P1, P3. How about P2, P4? Let's look at P2, P4, right? For P2, P4, we're going to be applying the same formula. P2, P4, we're going to be applying the same formula. So P2, P4, we will be applying the same formula for it, right? Which is going to be these two, the same formula here. And meanwhile, we need to get our P2 and P4. This is P2. Wait, sorry, I'm just going to erase all of these, okay? I'm going to erase all of that. Okay, so P2, P4. So what is P2? P2 is here. P4, what is P4? We identify P4, right? This is a P4. Okay, P4. And we're going to keep the letter P4. The simplified P4. P2, P4. Right? So for P2, P4, we're going to find the length. We're going to find the length. So square root. Square root. This is x1, y1, x2, y2. Okay, so we're going to replace x1 by cosine A, x2 by, oh, sorry, this should be B. Sorry, this is B. Okay, I think I might have a typo there. This is a B. Okay, sorry, this is a B. Okay, because this is a cosine negative B, and that's a cosine B because it's even function. Okay, so x1 minus x2, x2 is a cosine B. y1 is sine of A. So sine of A. y2 is a negative of sine of B. Negative sine of B. Oops, my bad. y2 is a negative sine of B. Okay. Now, we put this in. Sine of A minus negative sine of B. So negative, negative makes positive. So here we can put a plus. Okay. And next, we're going to apply the formula that we applied earlier, right? X minus y squared. So that formula applies to the first piece, right? And we also have another formula, which is, we can just go there, right? And x plus y. X plus y. Okay, for x plus y, if you FOIL that, you're going to get this other formula, which is going to be x squared plus 2 times xy. So these two formula will be applied to our situation. Okay, so on the first one, we got equal, right? Cosine A minus cosine B. So this is a capital X and this is a capital Y. So we apply the first formula. So we're going to have, okay, so I'm going to bring it over here. And this piece will be replaced by cosine square of A minus 2 times cosine A times cosine B plus cosine B, cosine square of B. On the other piece, it is going to be replaced by using this formula where sine A is a capital X, sine B is a capital Y. So this piece will be replaced by sine square of A plus 2 sine of A, sine of B, plus sine square of B. Okay. So now let's see what we got. Okay, we're working on P2, P4. We are working on that line now, right? Look at this. Look at this. Okay, I'm going to copy this and paste cosine square of A. There's a sine square of A. So these two makes 1. Okay, so these two makes 1. Cosine square of B, sine square of B. So these two makes 1 again. Okay, and what is more, if we add the two ones, if we add the two ones, we get 2, and this 2 is combined with the other one. This one combined with the other one. Okay, so we got this. So now we get P2, P4 equals to this guy, which is simplified. And P1, P3 is this guy. Okay, so we're going to bring these two together. Okay, so P1 is this piece, P1, P3, and P2, P4. P2, P4 is this guy. And they are equal, right? We knew, right? We've worked so much, right? We have identified that P1 to P3, this piece is equals to P4, P2, P2, P4. So these two secant lines are the same, straight line are the same length. So now if they are the same length, right? So these two, right? So P1, P3 is equals to P4, P2, P4. And that is leading to the next relationship, which is that guy equals to this guy. Okay. With that done, suppose, how about we square both sides, right? If we square both sides, we will get the inside of the square root equals to the other one inside of the square root. There we go. And there's a 2 on the left, on the right, there's a 2 on the left. So we subtract 2 on both sides. If we subtract 2 on both sides, so we get rid of the 2, so we're using principle number 3, right? Equals to negative of that. And 2 and 2 reduced, right? We subtracted. And next, we divide every term by negative 2. We divide every term by negative 2. So this piece, we divide by negative 2. That piece, we're going to divide by negative 2. And the last piece, we're going to divide by negative 2, right? Principle number 4. And the left-hand side, negative 2 reduced. So we're going to have cosine A plus B. And that would equals to the right-hand side, negative 2 divided by negative 2, that makes 1. So cosine A, cosine B is left. Okay. 2 divided by negative 2, that's going to be negative 1. So this plus become minus sine A times sine of B. Okay, so this is the ultimate identity we want to prove in this section. Okay, now with this done, what is to look forward to? What is to look forward to? What's to look forward to is that we're going to have a map of a set of formula we're going to derive. Okay, these set of formula are often used. So we're going to spend some time I'm going to show you how to derive them. If you guys would follow me to go through the deriving process, I promise you it's going to be so helpful that you will probably find yourself not having to memorize them. Instead, you can just derive them at your fingertips. Okay, so without further ado, and next time we're going to talk about how we can derive, right? So this piece is done, right? End of proof. Okay, so now we know this is true. So from this, we're going to derive a bunch of other very useful formula in the next lessons. Thank you for watching.